First of all, I'd like to welcome you all. It's good to see that people are interested in our school, in our degree programs. My name is John Sheridan. I am been in the situation you are in the sense that I left Ireland. I got a degree in Ireland, and then I left to study in America. I did a master's degree in Georgia Tech, and then I went on to do a PhD in England, in Oxford. After this, I then traveled to work in Germany and in Italy before I eventually returned here to Ireland, and I've spent time as well in Japan. So I know the sort of situation you may be in and your interest to travel abroad and to study abroad. Our program here is quite broad. We have a very large school with 40 to 50 members of staff. We have a number of degree programs, which I'll talk about, master's level degree programs, which I will talk about, maybe some of the ins and outs associated with that. I'm an optical engineer myself, so that's my specialist expertise, but I'm now the head of the School of Electrical and Electronic Engineering. And I suppose the one thing I should say before we start off is that here we tend to associate electronic engineering with things like circuits and signal processing, so information. And we tend to associate electrical engineering with things like power generation, sustainability, and electrification. So those would be the first two things I would, because I know that the nomenclature, the way people name degree programs, etc., varies across the world. Okay, so let me just put up a slide here for a moment. I'll share my screen, and I'll just bring this up here and put this in front of you. Let me see if I can just display this here. So we use the full screen. So can everybody see that? I hope so. I hope everybody can see that.
It's not showing us full screen yet.
Oh, excuse me. So let me just see something here. I think it may be, excuse me. I see it seems to be coming up on my other screen. So excuse me if that's what's happening. Let's just, we'll stick with this maybe. This maybe will be okay.
Yeah, that's fine.
That's fine. Okay. So again, electrical electronic engineering and meeting the future needs. So we essentially have a set of programs. So for example, we start most of our own students in the third year, they're asked if they want to complete with a BSc, which then would allow them to go ahead, for example, to continental Europe and do a 2-year master's programs. But we offer 2-year master's programs here in, for example, biomedical engineering, in electrical power engineering, electronic and computer engineering, and also in optical engineering. And we offer 1-year MSc Eng programs in electronic and computer imaging and optical engineering. And we've just started, or if you'd like, we just started to organize one in electrical power engineering as well. I also note that we have just started also professional diplomas. These are maybe more targeted towards people who, for example, might be in industry and they'd be interested in upgrading maybe the skill set they have, for example, taking something like 20 extra credits or something like this. All of these are the ME programs, so the 1, 2, 3, 4 ME programs. These are 2-year programs. So you would come here and you would take courses for the first trimester. So that would be between September and December. And then starting in January, you would take a 6-month or 8-month internship with industry. This is for all of these ME programs. And then in the second year, you would come back and again, you would take courses in the first trimester before Christmas and the trimester after Christmas. So let's say completed by May, but you would also do a project, quite a substantial project. Roughly worth, each course would be worth 5 credits. The projects and the internships are both worth 25 to 30 credits. Now, typically, after the people have done their internships, they would return. They'd generally be much more serious. And these internships will be paid internships. So the companies would pay the students. And we pretty much have all the students who want to do internships get to do internships, 6 to 8 months, as I said, in the company. And often during these internships, they'll work in teams, there'll be group work. And when they return after the internship, they'll then have maybe a clearer idea of maybe some of the courses they want to study later. They may decide to go into a different area than the area the company was working in, or they may even do a project which is related to the work they did in the companies. One of the things we've noted is that from our internship program is that approximately 70% of the students who undertake internships in companies are offered jobs by those companies. They're offered jobs by those companies. And then about 50% of the students actually take those jobs. So again, when you apply for the internship, it's a competitive process. You may have several students applying for the same internship. So the company may decide to choose you, or you may be offered a job with the company and you may decide you don't want to go to that company. In the final year, as I said, often the internship impacts upon the courses people choose to take. But the major part in the final year would be the project. And so people can propose their own projects, but mostly these are projects that are offered by members of staff. And if you want to propose your own project, you have to find a member of staff who's prepared to take you on. So just in terms of these, the MEs, we have biomedical engineering. And of course, this deals a lot with things like signal processing. There's both electrical emphasis on electronic aspects and also mechanical aspects through mechanical engineering. But in our case, a lot of the work involves things like signal processing, biomedical instrumentation. We have the ME electrical power engineering, and this is very advanced in Ireland. Ireland has a very, very long history, and we're one of the most active countries in the world in this area, probably because we, first of all, have to generate almost all of our energy on the island. We only have very few interconnections with other countries. And we also have to supply power very, very stably because we have large companies like Intel working in the island. And we have a huge amount of wind generated electricity. So we have, for example, an energy institute on campus as well, which is very, very active and world recognized. The ME electronic and computer, again, as I would stress here that the electrical people are interested in power, the electronic people are interested in signals and information. And so this is one of our oldest programs. And in this case, we have a very active local industrial base, companies like Intel, and there's a government-run organization called Midas, which is basically controlled by industry, and they would have a lot of jobs offered up there even at the moment. So we're very active, many opportunities for employment as electronic and electrical engineers. And again, the electronic and computer people are interested, for example, in information and processing information, but things like machine learning, which comes into all the different ME programs, artificial intelligence, Internet of Things, networks, telecommunication networks, all of these things have become more and more important. And as you can see, there's interdisciplinary. Every one of these ME programs has modules which will be taken by students in the other areas. For example, there will be a course on entrepreneurship and professional management. And many of the students taking these ME programs would also take those courses as well. Now, I would distinguish the ME programs from the MSc programs, these MSc. These are one-year programs, and typically we would have students come and they would already have a BE, for example, and they would undertake this program, and this program involves also a project, but it's much more condensed. It's over 1 year period. I would notice in relation to this that the students who undertake these programs are eligible to stay in Ireland and look for work afterwards. And many of the students who undertake these 1 year programs do so. And again, we have MSc programs both in electronic computer, in optical, and we have a new one now in electrical engineering, power engineering, which will be coming online, I think, next year. The ME optical is very similar to the others in terms of structure, but there will be an emphasis on, for example, if you're processing information, it will be using optical fiber telecommunication networks, or we'll be processing imaging data. So there will be links there with biomedical. And there would also be things like use of high efficiency lasers for reduced power consumption or applications in other areas, like, for example, telecommunication security. Again, we have a 1 year program, which again, as I said, is pretty much the same 1 year and without the internship and without this deeper project. And then we have these diploma situations. The School of Electrical Engineering, we have a very good ranking. So again, Ireland is a relatively small country. And one of the things I always say to prospective students is they should be interested to come here. It's quite a safe country. It's expensive, it has to be said now, and it's become more expensive recently, but it's a relatively safe country. We have a very good ranking, both in terms of the university itself and in terms of our actual program, our electronic electrical engineering program itself. We've got a large number of fellows of the IEEE, the largest number of any university in the country, and fellows of other professional bodies, Optical Society of America, Optica, and SPIE, Optical Engineering Society, and also Applied Mathematics. So we've got quite a lot of research funding, and so our professors are very active researchers. All of our staff members are doing research. Very robust research profile, and I certainly urge you to go and look at the UCD profile. What you'll see is you'll see the modules, descriptions of the modules, the actual courses you take, the learning outcomes and what's required of you in great detail, and also the profile and strengths of various staff members. It's all there on the web. Leading research profiles and enabling technologies, Internet of Things, sustainability, all these very good, solid engineering things that people are interested in now. Very strong record of innovation. Very many members of staff have actually started companies, or they sit on the boards of companies, or they perform consultancy for companies for which they're paid. Graduates are feeding a robust national ICT sector. As I mentioned, MIDAS. Again, you can look in there and you can see the big range of electrical engineering companies out there. You can also look up companies in the area of biopharmaceuticals and biomedicine, very, very active areas in Ireland across the country. And we've got a large number of influential graduates worldwide. We have former members and graduate members who, for example, vice presidents of Xilinx, Google, Intel, people who've reached the very highest levels in their own areas. And I mentioned here in relation to research, we have the energy systems, signal processing integration, Internet of Things, biomedical imaging. I could mention also things like quantum mechanics and advanced manufacturing techniques. Very, very active areas of work, all of those. The key sectors, graduates feed into Irish ICT, so semiconductor manufacturers, high frequency circuits, networking, Ireland compatible profile, substantial clean energy resources. I said we're even treated as sort of a laboratory for the green energy and electrification. So production of electric cars and the use of electric cars, moving away or decarbonizing the environment. Energy employers, including whole ranges of employers, some of them that you might think has been associated more with, for example, bioagricultural or even biomedical or with power, but our graduates go into all of these large range of industries and are very successful in them. We train people to be good engineers and we train them how to learn. We emphasize the basics and applying the knowledge that you learn. And we've got a technology, Ireland's very much global technology hub of choice, attracting strategic business activities. Of course, the native language here is English, and we want our graduates to be able to read, write, and speak in English. We have industry, 37,000 people in direct, but there's a huge number of people in indirect series of images. And our graduates go to work in things like financial services, in banks, even for accountancy firms, okay? Second largest software exporter, huge amounts of work in this area. People like Amazon are based here, Facebook, huge opportunities in those areas. Also the harder end of technology like Intel, HP, IBM, and Microsoft and Apple, long established operations. So these are not people who showed up a few years ago. Some of these have had bases here for 20 years and 30 years and more, and they're not going to go anywhere. And joined by newer giants, Google, Facebook, LinkedIn, Amazon, all of these, let's say, people who've come here in the last 10 to 15 years and are very active as well. And then I'll finish up here and I'll come to the questions. If you want to find out more, please go to our website. You've got some contact information. If you're interested, please contact people and ask for more information. I'd be very happy to try and help you find out more about what's happening here and how we go about things and how we do things. Okay, so I see there's a couple of questions here. The first one, Roman P., a question concerning the master's thesis in the biomedical engineering master's. Is it possible to write a thesis about my own project? So the answer here is that when you come here, as I said, the first thing you're going to do if you're doing ME is you're going to come here and you're going to have courses up until Christmas, so September to December. And the university will help you to find an internship. So you're basically going to be found an internship where the company will pay you. Okay. And as I said, the vast majority of people have absolutely no difficulty in finding a good internship position. Then you will return in the second year of the ME, and at that point you have to choose a project. And there's a couple of paths here. The first path is that the members of staff offer projects, and you get to choose. And essentially, it's operated on a competitive basis, and it's based on on the marks you've received already in your coursework. Okay, so if you're top of the class, you typically get the first possibility of all the options, all the projects offered. You also get the opportunity to propose a project. Okay, so you can propose a project, and some of the students come back from their internships and they actually propose projects combined with the actual company, or we have students who propose their own projects. At that point, you've got to find a member of staff who is willing to accept you and who is willing to supervise you to work on your own project. Because of course you need to have a member of staff who's going to oversee what you're doing and understands what you're doing, can help you do what you want to do. Yeah. If you come and you're in biomedical engineering and you say, oh, I want to do a project about kangaroos, then we have to find a professor who knows about kangaroos. Okay, so yes, students have proposed their own projects in the past, and yes, we have taken them on, but it's a difficult process. It's not an easy option. Yeah, it's actually a lot of work, because you have to convince people that your project is a good idea. Okay. I'm working on a new approach to EMG acquisition. Well, we certainly have staff working in that area, the signal processing of EMGs, using advanced techniques like machine learning and AI, for example. So you may well be able to find somebody who's prepared to take you on. But if you come from the first year, the first thing you would want to do is start making those links, going to the appropriate courses and seeing what's going on. Sometimes people, for example, will come to us with a very clear idea of what they want to do, but then they go and they do an internship and they realize, well, I really don't want to do that anymore. Now I want to do something different. Or they might even go to an internship and then say, I want to keep going to do that. So, you come, you show us what you've got, you see what we're doing, and you decide how the two things can be married together to get you the best result for you. Okay? And we'll be overseeing this. So we're not going to let you go crazy. That's very important. Okay, it's good to be ambitious, but it has to be practical. It has to be good engineering. Okay, so there's a mention from Abharim. Can you tell us about research in 5G? So we have a number of staff who are very interested in. So first of all, you must understand that there are different layers here, different technological layers. So we have people who are working, let's say, at the very lowest technological layers in terms of IC fabrication and manufacturing. So very fine level. And again, the whole idea would be that you can make circuits denser, smaller, higher speed, lower power, etc., which are all critical to the functioning of very high frequency circuits, which in many ways are at the base level of things like 5G or 6G. Then we have, and there's exciting areas there, which include things like circuitry that does quantum compute calculations and processing based on quantum computing in parallel, which again increases typically speed, or that's the idea. We then have people who are working on things like high frequency, high power drivers. So these would be, for example, the circuits that might take this information and then would, if you'd like, drive something like an antenna. So you've got to take very low power signals and turn them into higher power signals for transmission. But these circuits have to work at very high power, and they have to work linearly. Okay, so that you don't. So we have members of staff who are working in those areas. And then we have members of staff who are working on things like higher level associated with the network, the actual telecommunication network, and for example, the protocols, the software associated with the operation of those networks. So we have people working in all of those various areas. And again, if you're interested in some information like that, please go to our website. You can look up, for example, in terms of networking theory, you have people like Professor Mark Flanagan. In terms of these high power RF circuits, you've got people like Professor Anding Chu. In terms of IC circuitry, we have people like Professor Peter Kennedy. Again, all of these people, many of these people are fellows of the IEEE, and so they'll be very well respected in their own area. I hope that answers your question at least a little bit. Is there any work on wireless communications? This is from Amir. Yes, and again, wireless communications has again several aspects. There's what you might think of as the microwave, terahertz, and optical regimes. So there are very different physical manifestations of wireless communication. We have line of sight, free space optical, people working in that area. We have people working on antennas And if you'd like, if more maybe what you might be familiar with in terms of Bluetooth and ideas like this. And again, the frequency range and the power range associated changes the actual emphasis. But again, we have people working in all of those areas. How about the job prospects, in particular electronic hardware design after MSc? So again, I would direct you to an organization called MIDAS, M-I-D-A-S. It's an employer group. The industry comes together and form this society. And what they do is they advertise jobs. So MIDAS in Ireland, and you will see there a range of the jobs that are currently offered. Some of them are lower level technicians, some of them are higher level, but we have former students who've gone on to work in companies like Xilinx, yeah, or in Analog or Intel, again, at different levels within those companies, all the way from, if you like, hard in fabrication to testing to manufacture and design. Okay, and all of those things are happening in Ireland. So many of the people who go to those companies are sent abroad, for example, for training. So our students would go, for example, to work with an Intel or Analog, and they would be sent after a couple of years. They'd be sent to headquarters or specialist training, for example, in America. That's typically where they would be sent. We also have links with companies like TSM in Taiwan, all over the world. Our professors have groups, research groups that are designing and building and mapping out actual chips. So it's not just maths and theory. We actually make things as well, and we see them working, and then we test them. Okay, and then some of our professors go on and they actually make companies. Okay, so we have a broad range of interests and skills sets available. So let me see now. I can see on the, so that there's, I can see there's some information there in that Laura has given you there for staff profiles. And also she's given you the link there from Midas. If you go into the chat, you'll see those links there. Again, that gives you very much a feeling about what's happening here. At the moment, we've just to let people know, we've actually relaxed our COVID restrictions. So we've been doing face-to-face lectures. Lectures typically also come with lecture notes, and also most of the staff also provide links for lectures. We have laboratories. You'll be, depending on the modules you take, you'll be expected to participate in laboratories. Typically in our laboratories, we have teams, we have groups of between 2, 3, and 4 students, never more than 4, working together at a laboratory bench, typically 2, under the direct supervision of a professor and also teaching assistants, but there will always be a professor in the room. And all the lectures are given by professors. So we don't have postdocs or TAs lecturing to you guys. The professors themselves actually do the lectures. We also have things like there's very active student bodies. So we have the electronic ElecSoc, which meets regularly. They have a robot section, and they have a section that does with unmanned vehicles. They build things and they write software. We also have a society that works on electric car, racing cars, electric cars. And every so often, I understand the students go out and do karaoke. Okay, so it's quite sociable, yeah, which I think is also quite important. Of course, you know, if you don't want to meet or talk to anybody, you're not going to be forced to, but we try to encourage people because, again, it's what engineers do. They work in teams, they work together, they have study groups. It's good for them. Okay. Now, I don't know if there's any other.
No, John, I think we've got all the questions covered. I thank you very much for your presentation and for covering the questions. I think that's all the open ones we had.
Okay.
As John said, popped a couple of links in the chat if you want to check those out.
Very good.
Profiles, if you want to find someone maybe has a research area aligned with what you're looking at. As John mentioned, Midas. I've also put a link to our ElecSoc and our UCD Forum, the student societies there, as John mentioned. I am also going to pop in my email address, if you just bear with me. So if you do have questions that come to you after the event today, or if you're making an application to us and need a bit of help or support, you can reach out to me directly. I'm more than happy to have a conversation via email, or I can set up a phone call or a Zoom call to have a more in-depth conversation with you as well. Also, if you want to kind of get the student perspective, we do have one of our students of the Masters in Electronic and Computer Engineering with us on our live chat today. So if you go over to our engineering booth and go to the live chat there, you can chat with that student, or some of our other staff are available to answer more questions for the rest of this afternoon. So head over there. And then also just to flag with you, we are having a college-specific postgraduate event in April, over April 5th and 6th. We will have a specific session for electrical electronic engineering, where we'll have a couple of our current students and also some of our alumni speaking about their experience as well. So you should come along and check that out. So I'm just going to pop a link in the chat to the Eventbrite registration for that. If you bear with me.
I might mention that we also have within the school, we have several student chapters of professional organizations. So for example, there's an organization called the IEEE, Institute of Electrical Electronic Engineers, and we have a student chapter. Students would join, and then basically they have meetings and talks. We also have student chapters of the International Optical Engineering Society and a society called Optica. So again, there's lots of opportunities. If you have a particular area of technology that you're interested in, there's opportunities for you to meet and mix with students with interests in those areas. Again, these are not obligatory or required, but you know, it's a nice way to meet people and to do things or work on things that you're interested in yourself. How you know, people actually, as I said, I mentioned, they're, as part of our LexSoc, they actually meet and they talk about robots and they build robots. We, in our first year of our undergraduate degree, we have a thing called Robot Rugby, where actually our undergraduate students build little robots and they have football games and things like this. And so, you know, it's a very much a hands-on thing. You know, we try to get people involved, and we like it when people are involved and want to learn and do things, but they're not required. Okay. Again, I just would stress again, Lord, the fact that it's a nice campus, it's safe, it's clean. You know, Dublin, as I said, is expensive, so make sure you check that out. But I think it's a very good environment to be in if you want to do engineering.
Yeah, thank you, John. I think that's really good for our attendees listening to know those really great insights. And I think I should also say that the School of Electrical Electronic Engineering has some really great academics, really great. They really care about their students. They have open door policies and they're very approachable. So I think that's also worth noting as well. So I think we've come to pretty much the end of the session today. The last link I'm going to pop up in the chat is just a link to our college YouTube channel. So there's a lot of videos there that our attendees might find useful, but also I know some joined maybe slightly late. So if you missed the start of this presentation, I am going to pop the recording of this up early next week so you can catch it there as well. So the last thing I want to say is thank you, John, again for your presentation, and thank you to our attendees for joining us.